In this next section, we're going to be talking about the second of the three major fossil fuels, which is oil. Crude oil, which simply means unprocessed oil, is usually a black or dark brown liquid, although it can be other colors, and it's composed of hydrocarbons. Oil is the most widely used of the three fossil fuels. It's responsible for about 31% of global energy production, and it's primarily used for transportation as a primary energy source. But oil is also used as a raw material for the manufacturing of plastics, synthetic fabrics, synthetic rubber, and much more. So just like in our last section, when we talked about coal, we're going to go through a bit about how oil is extracted from the earth, how it is processed, and then the consequences of its combustion. So oil is drilled out of the ground from both onshore and offshore wells. Onshore means on land, offshore means in the ocean. Of these two methods, onshore is much more common because, as you can imagine, offshore wells are more costly because they involve building platforms or erecting rigs that float on the water in order to drill and maintain the well. Offshore wells can also require the drilling to occur at very significant depths under the ocean. So offshore drilling rigs may operate at ocean depths of 2 miles or more. And once the crude oil is extracted, it gets transported via tanker ship, train, or pipeline to a refinery. And each of these methods of transporting oil carries its own risks of leaks and spills. We'll talk about leaks and spills at the end of the section. The bottom photo here is of the Trans-Alaska Pipeline, which runs 800 miles from the Arctic Ocean down to the Gulf of Alaska. And once the oil makes it to a refinery, the first step in processing it is called separation. And separation is necessary because crude oil is not just made of one type of hydrocarbon. So for example, water is H2O, it's just one molecule, but crude oil is a blend of various hydrocarbons and also contaminants that are all mixed together. So during separation, these various hydrocarbon molecules are separated from each other through a process called fractional distillation. And fractional distillation relies on the fact that smaller, lighter weight hydrocarbon molecules have lower boiling temperatures, while larger, heavier hydrocarbon molecules have higher boiling temperatures. Therefore, when you boil a batch of crude oil, the stuff that evaporates first is the lighter weight hydrocarbons, like gasoline, for example, and then once it's vaporized, you can collect all of that gasoline vapor and cool it down and then condense it so that you just have that one pure type of hydrocarbon, which has been extracted and separated from the blend. And then if you keep increasing the heat, the next smallest hydrocarbon fraction will evaporate next, and then it can be condensed and collected, and eventually you're left with only the heaviest fraction, which includes molecules that are used to make paraffin wax and asphalt, for example. So this is how the crude oil is initially processed. The second step is called conversion. And during conversion, certain fractions that were obtained during the fractional distillation are transformed into other products. And this can happen in a few different ways. Cracking involves breaking large hydrocarbons down into smaller ones, and that's what you see represented in this image here. Unification is the opposite, combining smaller hydrocarbons into larger ones. And then the alteration involves rearranging the parts of the molecules to create different forms from the same set of atoms. And the purpose of this conversion step, however it takes place, is to create different molecules that can serve different purposes. The final step is called treatment. And treatment removes impurities such as sulfur, nitrogen, and water from the various fractions that were distilled and converted. It also involves combining different ratios of fractions to create products. So for example, gasoline that has different octane ratings. And the octane ratings are those numbers that you see on the different pumps at the gas station that correspond to like regular gasoline, plus gasoline, or premium gasoline. Those different types of gasoline are made by combining different ratios of hydrocarbon fractions. The most common products that come out of the treatment process are gasoline, diesel, heating oil, jet fuel, waxes, asphalts, and feedstocks for producing various manufactured products, meaning the raw material that goes into making things like plastic or synthetic rubber. So that's how oil is obtained and how it's processed. What about its impacts? So first we'll talk about the impacts of oil drilling and transport. So just like coal mining can disturb ecosystems, oil drilling can as well. Erecting onshore oil wells and offshore oil rigs, as well as all of the infrastructure that has to be created to transport oil, like pipelines and roads, those can all contribute to ecosystem destruction. In addition, all of that infrastructure often results in the pollution of soil and water. But the routine sort of pollution that comes from this infrastructure is really a drop in the bucket compared to what happens when there is an oil spill. So, oil spills can originate from accidents at wells, accidents with tankers, or with pipelines. Spills that occur at sea are far more damaging than ones that happen on land because the water disperses the oil very efficiently. It can travel hundreds of miles, it's very difficult to contain, and it covers the water's surface with a layer of oil that's very harmful to marine organisms. It can kill seabirds, mammals, shellfish, other organisms that get coated in the oil. And to give you an idea of how dispersed the effects can be, the famous BP oil spill that happened in 2010, which is what's pictured in these photos, released 134 million gallons of oil and it coated 1,300 miles of US coastline in the Gulf of Mexico. And that's not to say that onshore oil spills aren't also very problematic. Pipeline accidents have spilled an average of 76,000 barrels of oil per year since 1986. The largest ever land based oil spill in Asia, which was the Mingulak oil spill in Uzbekistan, involved a well blowing up and spilling 2 million barrels of oil, which ended up burning for 2 months. Of course, the environmental impacts of oil are not limited to those that are tied to its extraction and transportation. The combustion of oil also has environmental consequences, and unsurprisingly, these are largely the same as the consequences of coal combustion. The burning of oil products emits a number of criteria pollutants, including carbon monoxide, sulfur dioxide, nitrogen oxides, and particulate matter, which are not just harmful for the environment, but also for human health. And of course, oil emits carbon dioxide, which is not considered a criteria pollutant, but it is the significant driving force between the enhancement of the greenhouse effect and climate change. In the next section, we'll be turning our attention to the third and final fossil fuel type, natural gas.